So in this video, I want to ask you a question. What if you're given a function, let's say in x and in y, and it is x squared plus 4xy plus y squared is equal to 1? And what if you are asked to solve for y prime? Now, we simply cannot do that here because this is not explicitly solved in y. So we have been dealing, in the previous video, we have been dealing with y as a function of x, so it is explicitly solved in y. We have our clearly stated the independent and our dependent variable, so we have y as a function of x. And we have been given, I have given the standard formulas for differentiation, no? Like the formula for derivative of a quotient, a product, a sum, derivative of x to the n, and we have already also established the chain rule, okay? But what if the equation that you are asked to derive is in x and y? So these equations are called implicit functions. These are called implicit functions. So how are we going to get the derivative of implicit functions? So the answer is simple. We just have to apply this rule. No? And the rule is get the derivative of each term. So let me write that down. Or differentiate. Differentiate each term with respect to x. Okay? With respect to x. Because we want to get, again, we want to get y prime. Okay? And y prime is the derivative of y with respect to x. So if we differentiate each term, okay, if we differentiate each term, then we need to get the derivative with respect to x. Okay? So if we apply that rule here, if we apply that rule in this example, so we have x squared plus 4xy plus y squared is equal to 1. So according to that rule, differentiate each term. So differentiate x squared with respect to x. Then differentiate 4xy with respect to x. Differentiate y squared with respect to x. Then of course, differentiate 1. We already know that that is a constant and this will be equal to 0. So if we will get the derivative now, x squared is 2x, okay, with respect to x, plus this is 4x, this is product, okay, we'll apply product rule, 4x derivative of y, okay, derivative of y with respect to x, plus 4y derivative of x with respect to x, and then y squared, derivative of y squared. So we have 2y, okay, applying the derivative of power formulas, okay, so 2y and then 2 minus 1, then derivative of y applying chain rule with respect to x, so equals 0. So our derivative of y with respect to x, this will be y prime, okay, because that is the derivative of y with respect to x, and the derivative of x with respect to x will become 1, okay. So let's go ahead and simplify that in our next page. So we have 2x plus 4x. Then I have told you that derivative of y with respect to x is y prime. That's very elementary. Plus 4y. Then derivative times derivative of x, which is 1. And then plus 2y, y prime is equal to 0. Okay, so let me just check. Okay. So what we now have here is the differentiation. We are now done with getting the differentiation, okay, of the function, of the implicit function. So what is left to do is to solve for y prime. So we will do some algebra here, and we will come up with y prime. So this two terms as y prime. So let me factor it out. So 4x plus 2y. And then transpose these two terms. So I will have negative 2x minus 4y. And then finally, y prime is negative 2x minus 4y over 4x plus 2y. You can go ahead and do some simplification here. Factor out negative 2 from the numerator. So this will be x plus 2y. Factor 2 from the denominator. 2x plus y. So 2 will cancel out. And we will now have our final answer, which is simply the negative of the ratio of x plus 2y all over 2x plus y. So that is how you get the derivative of an implicit function. Okay, so again, simply get the derivative with respect to x of each term, and then after solving that, solve for y prime. Okay, so let's go ahead and have some another example. So let's say I'm given x squared minus 2xy plus y squared minus 6x plus 2y is equal to 0. So again, apply the rule, get the derivative of each term. So derivative of each term with respect to x is very important with respect to x because we are solving for y prime. And y prime is the derivative of y with respect to x. So derivative of 2x squared is 2x minus 2x. This is derivative of a product minus 2x y prime minus, I should say, minus 2y derivative of x. And we know that the last term is xy derivative of negative 2. And negative 2 is a constant. So I don't need to write that. So let me go ahead. Y squared derivative is 2y y prime minus derivative of 6x is negative 6 plus derivative of 2y is 2 derivative of y. So y prime is equal to 0. So again, algebraically solve for y prime. So we can factor out y prime from those three terms, and I will have negative 2x plus 2y plus 2. Then transpose the terms with no y prime, so minus 2x plus 2y plus 6. And then solve for y prime, negative 2x plus 2y plus 6 all over negative 2x plus 2y plus 1. Okay, you can go ahead and still do some simplification. We can factor out 2 from both of the numerator and denominator actually. Okay, let me just correct it. I wrote 1, so this should be 2. Okay, so factor out 2 from the numerator. So 2, this will become negative x plus y plus 3. And then factor out 2 from the denominator, negative x plus y plus 1. Okay, so 2 cancels out, and the final answer will now be negative x plus y plus 3 all over negative x plus y plus 1. That is our final answer. Okay, since we have already discussed higher derivatives, okay, higher derivatives, we can also combine the concept of implicit functions to higher derivatives. Okay, so let's say we are given the implicit function x squared plus y squared is equal to a squared. So that is an implicit function. And what if you are asked to solve for y double prime, or the second derivative? So let's first solve for the y prime, first derivative. So 2x plus 2y y prime is equal to 0, a being a constant. So y prime is equal to negative 2x all over 2y. Okay, I can cancel out 2, and my y prime would be negative x over y. Okay, so that is my first derivative. But we want the second derivative. So y double prime is equal to, so this is negative x over y. We will apply the derivative of a quotient. So we will start off with y, then derivative of negative x, so that is negative 1, minus negative x, then derivative of y, so that is y prime, all over y squared. Okay, so let me go ahead and write that in case you have forgotten. The derivative of u over v is simply uv prime, or vu prime, sorry, vu prime minus uv prime all over v squared. Okay, so simplify, I have negative y plus xy prime over y squared. Okay, that is not yet the final answer. Although we are done with the differentiation part, we can substitute, we can simplify this differentiation by substituting y prime with x over y. Okay, so y double prime will now become negative y plus x times negative x over y all over y squared. Okay, so let's go to our next page. And y double prime is equal to negative y plus, or that will now become minus x squared over y all over y squared. So we have here a bit of a complex fraction. So our LCD for the numerator is y. So this will be negative y squared minus x squared all over y squared. So we know that the denominator will ultimately be y cubed. And we have negative y squared minus x squared. If I factor out negative 1, I will get y squared plus x squared. So what we have here is y squared plus x squared, and that is actually our given. Part of our given, x squared plus y squared is equal to a squared. So we can still simplify further. The second derivative of y is actually negative a squared over y cubed. Okay, and that is our final answer. Okay, so to recap the video, what we have learned is what are implicit functions, and implicit functions are functions in x and y, so it's not explicitly solved, and how to get the derivative of implicit function. Remember that we are getting the derivative of y with respect to x. So we have to differentiate each term of the implicit function. Okay, differentiate each term of the implicit function with respect to x. Okay, so that is how you will get the derivative of implicit functions. Thank you for watching the video.